Okay, so let's have a look at 2A then. A ball drops onto a trampoline. So there's my ball. Whoops, hang on a second. So here's a ball falling, and then it goes onto the trampoline. Now, what happens when it hits the trampoline is it bounces, of course, and goes back up again. So we've got stage 1, it's about to start falling. And then stage 2, we could say, well, we can split it up into infinite stages, couldn't we? But let's say stage 2, it's halfway down. Stage 3, it hits the trampoline. Then stage 4, it goes back up again. It's halfway up. And then stage 5, it's back up to, let's say, nearly its original height. So describe the energy transfers that changes to the energy stores from the point of release to the top of its bounce. So I'm not going to write anything down, I'm just going to explain it. As it moves from 1 to 2 to 3, it has gravitational energy at the top. So at the beginning, it's got gravitational potential energy, and that gradually turns into kinetic energy. So we've got gravitational potential energy turning into kinetic energy. And go on. It had gravitational energy when it was high up. If something is lifted up in the air, it has gravitational energy. If it's moving, it also has kinetic energy. But at the beginning, if we're dropping it, then it basically, we can say at the instant I let go, it's not moving, but it's immediately after I let go, it starts to move, and then it gets faster and faster. And at the same time, it gets lower and lower. And so that means gradually the gravitational energy is going down and the kinetic energy is going up. What's happening is the gravitational energy is being transferred into kinetic energy, but also we have some thermal energy being produced because I'm just going to zoom in on this a little bit. The thermal energy is also being produced because there's going to be some air resistance. Now that's what happens as it goes from 1 to 2 to 3. As it hits the trampoline, it's now hit the trampoline with and it's with a fair amount of force because it's got a lot of kinetic energy. So what's happening is that kinetic energy is now being transferred into elastic energy, and also again more thermal energy. That's what happens as it collides with the trampoline. Now, as the ball goes, as the trampoline sort of goes down and down and down, it stretches and gains elastic energy, and then it rebounds back. So you have elastic energy. So that's why you see a bouncy ball squish, and because it's, in fact, even things like ping pong balls, which don't look like they're squishing, but they will be if you watch them in slow motion. They're squishing, they're gaining elastic energy, and they'll bounce back. And when they bounce back, the energy transfers the elastic back into kinetic, and again more thermal, because there'll be friction involved in the expansion and contraction of the trampoline and or the ball. So then it goes back up, and so now we've got kinetic energy, and so we're going to have kinetic energy being converted into gravitational potential energy, or just gravitational energy if you like, plus thermal again. So that's the whole process. The difference, the thing to note though, is it says nearly to the same height, and if it's nearly to the same height, that means that this amount of gravitational energy here is quite similar to this amount here. Now, if that means that not much energy must have been lost, and the only time the energy was lost is as thermal. So we would say that not much thermal energy was produced each time. That's the only other thing you would add to that, okay? And then you want to use the word store. So we'd say gravitational potential energy is being transferred into kinetic energy store. That kinetic energy store is being transferred into elastic energy store, and so on and so forth. Yeah, okay? Right, that's just the first bit, so I'll save that now.